Hi guys. So in this lecture we'll be looking at calculation of number of functional groups in an organic compound as well as calculation of dB for those compounds only. So some previous lectures I actually mentioned about different functional groups that we'll be studying during this entire series of lectures on organic chemistry. So now the time has come wherein I feel you guys need some more practice on to recognize the different functional groups present in the organic compound. Okay, so we'll be having some practice on the same. Okay, so examples on functional groups, or rather identification of functional groups in organic compounds. So let me just erase it. Okay, examples on identification of functional groups in an organic compound and calculating dB for the same. Okay, so let us kickstart with some of the examples here. Okay, so I'll be trying an organic compound, and you just need to quickly tell me how many different number of functional groups are present in this compound. Okay, we have an H2 group here. It doesn't matter at this point of time whether you are able to recollect the name of any particular any particular function group or not, but the main thing here is you are able to recognize what functional group is present. Means, have you ever seen this functional group or not, or are you able to recollect the functional groups which we just discussed in previous lectures? Okay, so for this case, how many number of functional groups are there in this compound? So as you can see, this is a keto group attached, this is a alcohol group attached, this is secondary amine attached over here, this is ether attached over here, this is amide attached over here, this is ester attached over here, this is primary amine attached over here. Okay, so how many different function groups are here in this compound? So the answer would be 1, 2, 3, 4, 5, 6 and 7. So the answer is 7. And what is the dB of this following compound? For calculation of the dB, you just need to calculate the number of rings and the number of pi bonds in this organic compound. Okay, so number of pi bond for this organic compound are just number of pi bonds are 1, 2, 3. So 3 pi bonds. And how many number of rings are there? 3 rings. So dB would be 6. Okay, let's see some more examples. We have organic compound like and There is a carbon atom in between the two H groups, so let me erase it. Okay. And this. Okay, so how many different functional groups are there in this compound? As you can see, this is the keto group 1, alkene group 2, carboxylic acid 3, cyanide 4, isocyanide 5, ether 6, this alcohol 7, this alcohol 8. Okay, so how many number of functional groups are attached in this compound? 8. And what is the dB? How many number of pi bonds are there? 1, 2, carboxylic acid has a pi bond, 3, 4, 5, 6 pi bonds. And how many number of rings are there? Oh sorry, I forgot this pi bond, so total number would be 7, plus how many number of rings are there? First ring and second ring, 2 rings. So what is the dB? Sorry, let me just erase it. Okay, 2 rings, so total dB is 9. Okay, let us look into this example. C-double bond ONH2, this is amide group, this is cyanide group, this is sulfonic acid, okay, this is ester group, this is again carboxylic acid group. So how many number of functional groups are there? 1, 2, 3, 4, 5, and last one ether group 6. So the answer for this thing is 6 functional groups. What is the dB for this following compound? I think you can calculate the dB. Okay, fourth example is you need to calculate the number of functional groups for this compound. C triple bond H is the alkyne group and CH double bond CH2. So let's calculate the number of functional groups in this compound. Okay, so this is an anhydride group. Okay, this is primary amine, this is secondary amine, this is alkene, this is alkyne. So how many? I think are you missing anything? So are you able to follow this, that why this is called anhydride? Okay, and because the structure of anhydride was something like R, C double bond O and C double bond O again and then R. Okay, so if you are not comfortable with revising what was the anhydride group, so let me write it again, write that down again. So anhydride is nothing but R, C double bond O, C double bond O and R. So looking at this pattern, we can clearly see that this RC double bond OR is present in this carbon and this carbon. So, and this is R, this is nothing but R again. Okay, so this is an another group. I hope you are able to recognize it now. So total number of functional groups in this compound are 4. Okay, so let us calculate the number of functional groups in this compound. Okay, so how many number of functional groups are there in this compound? First is the keto group, another is the aldehyde group, another is the this is the amide group. If you are able to see it, that this nitrogen will be having 2 hydrogen atoms attached to it. Fourth one is the alkene group, and fifth one is the alcohol group. So total number will be 5. Okay, so I hope by now you are able to recognize the different functional groups attached in an organic compound. It will take us some more time, but to get a good feel on getting the total number of functional groups attached in an organic compound, you need to have some good practice on actually identifying all those different functional groups, revising the concept, seeing the video lectures again and again, and I'm pretty sure that you will have a good understanding and a good hand over all these concepts. And okay, so from the next lecture onwards, I'll be starting on with IUPAC nomenclature, so that you can have a good understanding on how different organic compounds are named. And that's all in this video. Okay, thanks a lot.